Hello guys, welcome to my YouTube channel. Today we the students from Sardar Patel Institute of Technology going to present our mini project on subject signals and systems. The title of our project is Security Buzzer Alarm. The mentor for our project is Professor Najib Gatte and Professor Shanti Swami. See the members of our project, me myself, Yashwant Jadhav, Gaurav Hadawale, and Shreyas Jadhav. We are the students from Electronics and Telecommunication Department. Now moving forward to the component used in our circuit. First is power supply. Second is rectifier diode, which is IN4007, diode D1 and diode D2. Third is resistors R1 and resistors R2. Also, a optional resistor called R3 is also present. Fourth is transistor Q1, which is BC547. Fifth is capacitor C1. Sixth is transistor Q2, which is BC549. And last is buzzer, that is speaker. Moving forward to the circuit diagram, you can see this is our circuit diagram. We have made this circuit diagram on the software called Proteus. Here you can see the two switches used to operate diode D1 and diode D2. This is resistor R1, this is resistor R2 of same resistance value, which is 100 kilo ohms. This is first transistor Q1, this is second transistor Q2. This is resistor R3 with 1.2 kilo ohms resistance value. This is capacitor. This is ground. And last, this is buzzer. So moving forward to the applications of this circuit. First is door or window security alarm. Second is cupboard or drawer alarm. Third is automobile security. Fourth is ATM security. Moving forward to the simulation process and working for the circuit.
Okay, so now we'll talk about how this burglar alarm circuit works in detail. The burglar alarm circuit operates with a combination of diodes D1 and D2, two resistors of 100 k ohms, and one resistor of 1.2 kilo ohms, two transistors Q1 and Q2, one capacitor, and one speaker LS1. Let's walk through how the circuit functions in sequence. When the circuit is in its idle state, that is, the switches are open, there is no current flowing through the base of the transistor Q1, which is an NPN transistor. This keeps the circuit in the standby mode, meaning the alarm is off and there is no sound from the speaker LS1. Now, when the circuit is triggered by closing the switches, we see that um, uh, a small voltage is applied to the base of the first transistor Q1. This voltage activates the Q1 by allowing the current to flow from the base to its emitter. Now, when the Q1 turns on, it effectively connects the base of the second transistor Q2, which is an PNP transistor, to a path that allows the current to flow through it as well. Q2 turning on further amplifies the current, and hence we get a larger current that is sufficient to drive the speaker LS1. As the current flows to the speaker, the alarm starts to sound. This loud noise alerts us to the intrusion. Interesting thing to note is that the capacitor C1 plays a very crucial role. When Q2 is turned on and the alarm is triggered, the C1 charges up and it holds the charge momentarily. This keeps Q2 in the on state for a shorter period, ensuring that the alarm sound continues briefly even if the triggering action here stops. In simple terms, the circuit stays inactive until triggered, at which a chain reaction occurs. Q1 is first activated, which in turn activates Q2, which in turn um, produces a very high current and it triggers the speaker to produce an alarm sound. The capacitor delays the turning off of the circuit, allowing the alarm to sound for a few seconds even if the trigger is delayed. To summarize, this circuit uses transistors to amplify the small trigger signal, turning it into a larger current that powers the alarm. This simple setup makes it effective for alerting to any unauthorized entry. Thank you.
So now, moving to the simulation part, let's take a closer look at how the circuit operates to activate the security buzzer. In this circuit, we have two diodes, D1 and D2, which act as rectifiers, allowing current to flow only in one direction. This setup is crucial to protect the circuit and control the signal flow. Resistor R1 limits the current flowing through D1, ensuring the diode doesn't get damaged. The second resistor R2 acts as a pull-down resistor to keep the transistor Q1 in an off state, initially preventing any unwanted activation of the alarm. Transistor Q1 acts as a switch. When an external input triggers the circuit, Q1 is turned on, allowing current to flow through it. So this turn activates transistor Q2, which connects to the buzzer. Capacitor C1 here plays an important role in filtering out any noise or unwanted signals, providing stability to the buzzer's response. Once Q2 is activated, the buzzer labeled as LS1 in this circuit emits a sound signaling that the alarm has been triggered. The entire setup ensures that the buzzer only activates when specific conditions are met, making it a reliable security alert system. Now let's run the simulation and observe the buzzer's response as the input triggers the transistors. So as you can see, the buzzer successfully sounds, indicating a security breach, and the circuit performs as expected. This completes our simulation of the security buzzer alarm system. Thank you.